All right, thanks everyone for attending tonight's webinar. This is one we've been putting in the schedule, I think since June, I think since the fire conference in UBCO, right? I think that's where we met. Yeah, so it's been many months. We've been trying to get Dr. Hessburg to come and speak to us. He is an awesome researcher around fire ecology and a number of other things, but was really impressed with his presentation. I've read a number of his papers. So super excited to have you on tonight. Welcome to the conservation webinar series. I already see a whole bunch of familiar names on there. The format for the webinar series is essentially 30 to 45-minute presentation followed by Q&A. If you have questions, please put them in the Q&A box if you're on Zoom, and put them in the comment section if you're coming in on Facebook Live. The reason for the conservation webinar is really to bring people up to speed, give them some education, let them engage with some of the subject matter experts on issues that matter to the public and to our members. Keep in mind that our presenter tonight, like most of our presenters, are not decision makers. Dr. Hessburg is a scientist, so if you feel your blood pressure rising and you see things that you think should change in BC, definitely ask him a question, but also definitely send a letter or meet with your MLA or MP is our preferred approach on this. So as it relates to Dr. Hessburg, Paul Hessburg is a senior research ecologist with the USDA Forest Service, Pacific Northwest Research Station, and affiliate full professor at U of W, OSU, WSU, and UBC. He is the 2022 to 26 president of the International Association for Fire Ecology and Distinguished Science for the USDA, International Association for Landscape Ecology North America, and AFE. His research explores wildfire and climate change effects on landscape and wildfire dynamics and the structure and organization of historical, current, and future landscape resilience. I think I got all of that. So Dr. Hessburg, really appreciate you coming on. We do really value your time. I think we're going to get a pile of people that tuned in on YouTube after this is put out as well. So I'll turn it over to you.
Thanks, Jesse. It's a privilege to be able to hang out with you all, and I look forward to the questions that you have for me at the end. Just a little bit of my background is I've been studying big landscapes and how they functioned historically, currently, and how they're changing under climate change. And so I'm going to weave a story about what I've learned and what I think it means for changing forest ecology under climate change, and what it means for wildlife habitats going forward in BC and throughout the larger region. So my take home is going to be that restoring forest landscape and fire resilience is critical to BC fish and wildlife. And over the course of my talk, I'm going to tell you how I got there. So when we look at really big landscapes like British Columbia, or beam out to see British Columbia and Alberta, or even south of the border, Pacific Northwest, inland Northwest, everything looks pretty much as it should be. But when you start to zoom in, what you see is pretty significant changes are afoot. And I'm going to begin by enumerating what I think some of the core changes are. And then I'm going to spend some time talking about what I think that means for processes in landscapes and for plants, animals, and fishes that inhabit the same landscape. All right, first a word about some of the key changes. Fire exclusion cultural burning went on for an incredibly long time. We're learning in North America now that for a minimum of 10,000 years and as many as 20,000 years, indigenous cultural burning was really important to firing the landscape and maintaining not only safe and secure conditions, but great habitat and foraging conditions for critters that they hunted, fish, and for a variety of plants that were critical to material resources and first foods. So the decline for fire exclusion really begins with indigenous burning and loss of that burning and dispossession. Livestock grazing comes along a little bit later, a lot of ditching and draining of the landscape for livestock. We start building the environment in different locations and colonies, and we don't like fire near our built environments. And really, fire suppression is one of the last things that happens on that timeline. So the exclusion of fire has been going on for a pretty long time. as we see the indigenous cultural burning effects in decline. Timber harvests emphasized the large old trees. They tended to be the fire-tolerant trees, survived a lot of fires. Smaller trees, typically shade-tolerant, filled in, particularly true in the ponderosa pine, interior Douglas fir forest, and some of the montane forests that are a little bit further in elevation. We often didn't burn the slash. We killed off hardwoods in favor of conifers. And so we started to see conifers invading large areas of the landscape. Bark beetles, large outbreaks have been responding to modern day overcrowded forests, lots of dead trees on the ground today. That's fuel for future fires. And with an awful lot of the fires that have burned already, those dead trees are falling down with the possibility of even worse fires in the next reburn. Climate change, it's a big deal in British Columbia. We can expect to see warmer, drier, and windier conditions, longer fire seasons, snowpack in decline. And if you think about it, snowpack, where the deep snowpack is, that's where we have an awful lot of forest growth. So warmer winters, declining snowpack, it's a big deal for forests. Human starts average about 40%. That's about a 10-year average. So we're a part of the fire ecology now, and we're actually changing it with human starts. Finally, we layer in later on smoke management. That's yielding unsustainable air quality, which is increasing future sizes and severity. The lack of application of prescribed burning, thinning and burning is leading to less sustainable air quality, which is a big deal for public health, and more smoke is coming out of the severe fires. Prescribed burning yields a lot less soot than wildfires. I want to show some picture examples of the changing of landscapes in a relatively short period of time, because talking about it is different. This is a comparison of dry ponderosa pine in interior Douglas fir forests between 1934, that's from the National Archives, and 2010, that comes from a buddy of mine who's a pro photographer, John Marshall. And you can see that the south slopes and the ridges that are staring out at us, those are the barer slopes, have filled in with trees. And so fires can move contagiously from patch to patch, where that was a more difficult prospect because topography had a profound influence on the fire regime. So these frequent fires occurring every 2 to 15 years in dry forests, they typically came in two flavors: low severity fire that killed less than 20% of the growing stock at any one time, or moderate severity, which killed up to 30 or 50% of the trees, but most of the trees survive each instance of fire. And there's some really neat stabilizing influences that come out at the patch to patch neighborhood scale. This frequent low and moderate severity fire, what it does is it leads to more of the same forest condition. We call that a stabilizing feedback. And essentially what's happening at each instance of fire, these frequent fires, as surface fuels on the ground are burning up, fuel ladders that developed since the last fire, they're being consumed. And so it's even not it's not the same scene, but what you see is conditions like the previous scene continue on the landscape. And what we see lacking these high frequency fires, trees quickly accumulate, like I showed you in the last landscape there. They accumulate, fuel ladders obtain, more dead wood on the ground, and so now flames can climb this layered subcanopy into the overstories. And that results in crown fires, which are pretty atypical for these drier forest types. There's more dead wood on the ground, there's more ladder fuels, lacking the frequent fires, dense overhead canopy, all these things together fuel the modern fires in these forest types. In the middle elevations, we see the interdigitation or interlinking of dry and moist mixed conifers. And in these elevations, what we see from the historical ecology is that patchworks of open versus closed canopy forest, forest successional conditions of all ages, and quite a bit of non-forest were common on the landscape at any one time. These fires were relatively less frequent, every 20 to say 50 years, because productivity was higher, wetter conditions typically obtained in the average growing season. And so ignitions, even though they would occur from lightning, very often fires would not take off because fuels were not available to burn. Three flavors of fire, two I showed you before, and also high severity fire were fairly common, but low and moderate severity fire probably added together, affected more of the landscape. High severity fire created some of these new conditions where you see forest is crawling back at a much slower pace. And you can see in the interval between fires that Douglas fir beetle and mountain pine beetle are thinning out the forest in the absence of these fires. Infrequent fires are more common further up in elevation. This is the area of the cold forest. And here I'm talking about lodgepole pine, Engelmann spruce, montane spruces, subalpine fir, and mixes of these forest conditions. This is a pretty typical scene that we'd see up high in the cold forest. At any one time, 30 to 50% of the forest was in a non-forest or a hardwood condition at any one time. And you can see absent fire, another kind of forest condition develops, which is much more heavily forested. And so in these conditions, moderate and high severity fires. Moderate is where 20 to 50% or more burns, and high severity is typically more than 70 or 75% is killed at each instance of fire. And here again, you can see between the 1930s and the present day, tremendous change has occurred across this landscape. All right, some take homes that start to really matter, and I'm going to pull them out a bit at a time. What we're finding out from our research is that forest reburning is what stabilized large landscapes, and I'm going to unpack what that means. So fires of varied size and pattern and severity created ever-shifting mosaics of non-forest and forest conditions, and I'll unpack non-forest quite a bit more further in my presentation. But they're basically conditions like wet and dry meadows, sparse woodlands, wetlands emerge when you take the trees off with fire. And most of these occurred in forest-capable conditions. So ongoing fires are continuously and irregularly overlapping each other over space and time. And the complexity of habitat conditions historically actually came out of reburning. This shifting, reburned, and recovering mosaic regulated future fire size and severity, and that's the key ingredient that's missing today. Patches of hardwood forest are more mesic, and they would slow down the expansion of fire. Fires would often go out at the edge of hardwood forest patches. Open canopy conditions would make it impossible for crown fires to obtain because you didn't have the canopy density to be able to trap the heat and support a running crown fire. Many factors worked like this to essentially throttle fire growth and fire severity. This is an essential learning. Reburning typically decouples fuel ladders and surface fuels from canopy fuels. So think about this in this thought experiment. The first fire kills patches of trees or partially kills patches of trees. And the next fire comes along and it consumes the material that's fallen down from the first fire. And over time, reburning starts to isolate dead fuels on the ground from the developing forest canopy. And what's really cool about this is you actually can stock more forest on the landscape because this connectivity between the dead wood on the ground and the developing forest canopy is required to support crown fires. So you can stock more forest if land reburning is on the table. So resilient forest landscapes were less conifer forested than we think. And today we're well over carrying capacity in terms of the density and the area that's forested, and the return of fire is inevitable to these landscapes. Here's a couple of cartoons to show how that existed at a couple of different scales. So here you can see 1800s era landscape, 2020s era landscape in the bottom rack here, and you can see how heterogeneity in forest structure leads to heterogeneity in fuel loading, crown fire potential, and flame length. And you can see when you lose structural heterogeneity, you now have high connectivity of high fuel loads, likelihood for crown fire, and flame lengths, which make it, which make it difficult for fire suppression to have much effect. The flames are too long for direct attack. And I want to show you here on this other scale, this is a 150 million acre landscape. This is the early 1800s for the interior Columbia Basin on this side of the border. And you can see how a low and moderate severity dominated landscape is now dominated by high and moderate severity. So the possibility for fires to go very big is a big deal in landscapes like these. All right, the mountain pine beetle, which we're all familiar with, is a native beetle. Here's the range of it, including big areas of BC and Alberta, and we know about the big outbreaks that have occurred there. And we can see the mountain pine beetle, a native in a non-native role. These areas used to be vulnerable in this example landscape, and you could have high mortality because you had ripe conditions for tree diameter, brood survival, and so forth. But the loss of the patchiness of the landscape has created high connectivity for broods of beetles to emerge and spread from patch to patch to patch. And what's more, winters are warmer, and the mortality, the overwintering mortality that we used to have is terrible by comparison. Back in the days when trees cracked like a rifle report, when we had those sub-zero temperatures, they were critical for creating low overwintering survivorship for beetle broods. And so we're having high survival through our winters these days as well. All right. I said I'd talk to you about non-forest conditions and resilient landscapes. So we've been studying the Bob Marshall and the Selway Bitterroot and a number of other wildernesses where we've allowed fire to come back over the decades. And this is a typical look that you would have seen in low elevation, ponderosa pine in interior Douglas fir in the low elevation, moving into spruce, montane spruce, lodgepole pine forest in the high elevations. There's a lot of non-forest on the landscape historically, and I'll tell you why that was not only critical, but why it occurred. Most of it was on sites that are forest capable. That means that if you planted a tree, they could grow forests on those landscapes. On average, we're finding from province to province that between 25 and 50% of the potentially forested area wasn't forested at any one time. Non-forest, just to clarify, are rock, water, ice, snow, places that can't yet become forest, but they're also recently burned bare ground, very new forests, sparsely treed savannas, wet and dry meadows, prairies, shrublands, and wetlands. And these ingredients, these non-forest elements, were really important because they limited future fire size and severity. Very often the non-forest elements had flashy fuels. So while they would burn often, they wouldn't burn severely. And they essentially knocked fuels down over very large areas because they were able to burn early and often. And so historically, really large fire sizes are not the news of the day. Essentially, large forest and burned areas had very heterogeneous fire severity outcomes. And I'll show you some of that from British Columbia towards the end of my presentation. So these features provide throttle control to fire growth and fire severity. And the reason why, it's a fairly simple physics problem. There's a tug of war going on between factors that grow forests on productive sites and then take them away during the fire season, during the hot and dry, windy part of the fire season. And very often they're the same variables that make it possible to be forest, but also take them away by wildfires that burn. And so essentially what happens is non-forest hardwood elements, wetlands, were an emergent property of this ongoing tug of war. And that tug of war is a big deal in landscape resilience. With climate change, our modeling shows us that this intensifies. And what that means is there's going to be more non-forest elements because of trailing edge ecosystems, and there are going to be more hardwoods as well across the landscape, which were in British Columbia in moist mixed conifer and in cold forest, a very significant landscape element. We can aid the climate-driven transitions. And that's a really key thing. When we look at this tug of war, we look at these mosaics, what we see is we can actually create transitions and get something for our trouble, but we got to do it right. Here's some data from provinces much like your own in British Columbia. Northern Glaciated Mountains is our version of the Okanagan Highlands. Northern Cascade Mountains is the stateside version of the Cascades. Blue Mountains are in this area right here. Upper Klamath Mountains are drier in southern Oregon and northern California. And these are the Southern Cascade Mountains, part of our Cascade Arc here. And what you can see is, I just want to show you how common non-forests were. PP means ponderosa pine or inland Douglas fir. And it basically shows you that most of our ponderosa pine types, regardless of province, didn't have enough cover to make the definition of forest. In the dry mixed conifers, so think Douglas fir and ponderosa pine, about 40% of that forest type was in non-forest. In moist mixed conifer, about 36%. You can read the numbers as well as I. And what it does is it adds up to very significant amounts of non-forest on the landscape. Sometimes as much as 70% of the landscape. In the Southern Cascades, we found it's flipped. About 75% of the forest productive area is actually forested. All right, and if you want to look deeper into some of these results, here's the Frontiers article where we published these results. So I mentioned that not only non-forest elements, but hardwood forests are key, and this is especially true in British Columbia. In this picture, you can see in these higher elevation cold forests that non-forests have obtained widely. And it made it difficult for these forests to burn because these environments are typically more mesic, and probably 80–85% of the time they reduce the fire rate of spread or they stop fire growth altogether. So there's kind of a wet blanket effect that's not for certain, but it's pretty high probability. And so these hardwood forests are a big emergent property in moist mixed conifer and in lodgepole, spruce, subalpine fir, and mixes of these. And these hardwood elements were critical to the landscape ecology of fire in British Columbia, reestablishing a larger role for aspen, alder, maples is really important. In the US, it's oak forests. Birch is on the decline with climate change, so it's not a credible element in this strategy going forward. All right, climate change. It's a big deal in British Columbia, as you well know. More extreme climate and weather is driving larger burned area, but we're finding out in meticulous anthropological and ecological studies that indigenous burning weakened this connection. And so the strength of climate change anomalies, sea surface temperature anomalies, for example, it weakens. So statistically, it was a weak factor rather than a strong linkage. And so reducing fuel and dense, well-connected forest is the weak link to changing fire growth and burn severity. If you're interested, here's some further reading on some fabulous studies that are showing us how indigenous burning really created very different climate insensitive landscapes through tens of thousands of years. Here's an example that we have illustrated here showing the effect of indigenous burning going on all the time in different parts of the landscape during the period of fire exclusion and a period of mild climate. We're pretty good at jumping fires and putting them out so we don't see big burn patches, but all the while we're losing non-forest elements. We're dewatering wetlands on the landscape. We're losing hardwood forests, and you can see the landscape densifying. Now it's very largely dense, and so we're seeing basically anomalous fire size and severity coupling on the landscape as a result of the factors that I introduced as the major change agents. All right, a lot of rapid changes in the Western North American climate. What are they? More people, more ignitions, it's hotter, drier, and windier. There's less snow, rain, and water for the forested environments. We've got smoky, sooty summers, big fires driving them, greenhouse gas emissions are rising, and that's leading to health impacts as well. And how the hell did we get here? Well, this simply put is how we got here. This shows you a comparison between the mid-20th century global average temperature and then temperatures referenced beyond that. And you can see that we've increased the global average about 9/10 of a degree C, and that's a significant warming. The extremes are worse, and it directly ties statistically to increase in greenhouse gas emissions. These are the big three. And here's what that means for the US and for Canada. What we're going to see is here I'm showing projected changes by mid-21st century, and this is comparing the 1981 to 2010 to the 2060 to 69 for the high emission scenario. Winters are going to get cooler, not colder. So warming temperatures. The shoulder seasons are getting hotter. You can see here represented by the April and October seasons. And then you can see that summers are just getting much hotter, even in montane locations. So here you can see the montane locations looking up here in lighter shades of orange. You're seeing those areas also getting considerably hotter. And what it really adds up to is by the end of the 21st century, northern hemispheric summers are projected to last nearly half of the year. And what that's doing is it's reducing the period of the snowpack. Summer growth is pinching out spring and fall. And so forests and snowpack are in trouble unless we get a hold of climate change and the rate of warming. All right, some take-homes for restoring climate and wildfire resilient landscapes. Current interior forest biomass isn't sustainable, but we can make it so using some of the recommendations I've provided. And one of the keystones is reestablishing burned and recovering mosaics, stabilizing the tug of war between the factors that are growing and removing forests. So making more wet and dry meadows, sparse savannas and woodlands, allowing areas of hardwood forest to obtain after severe disturbance. Reducing density is going to recreate more wetlands. It's amazing after fires how many wetlands we're seeing reemerge on our side of the border and yours. And then varying forest age density and tree species conditions. More open canopy forest, more woodlands, especially on south aspects and ridges. Restoring the positive ecological role of fire is incredibly important. Almost everything on the landscape evolved with an intimate relationship with ongoing active fire. And to get active fire back on the landscape, we need to incorporate indigenous knowledge and practices. They are completely consistent with Western science, and I think they lend braiding these knowledge systems and practices gives us all a bit of a superpower. Primary tools are cultural burning, prescribed burning where manageable, and then managed wildfires or modified suppression, and thinning and prescribed burning. And thinning can partially pay for some of the job. Biomass removal can go into a bioeconomy. And with climate change, the non-forest and open canopy forest conditions become increasingly important to restoring stability. And those are the kinds of transitions that allow us to be able to keep forest around rather than get the product of wildfires. And lacking active work in this space over the next 20 years or so, we're going to see landscape dynamics, and the coming dynamics will have been driven by wildfires occurring thus far rather than more thoughtful transitions. All right, this is an effect. This is the holiday fire burn in Oregon recently in 2021. 160,000 acres burned in a few days. And here you can see most of the forest area burned at high severity, but it transitions from a crown fire in untreated forest to surface fire where thinning and burning had occurred, and it does it within a few rows of trees. Here's an occasion on the same fire where the stands got thinned, patchy, gappy tree distributions, but the slash didn't get burned from the lack of fire all those years. And you can see the fire transitioned as it crossed the road through this stand, burned all aspects of the stand, but thinning and prescribed fire allowed most of the trees and the habitat conditions to survive. All right, I want to transition now some of these changes in forest landscape resilience and things that can return them to some take-homes for fish and some wildlife species. When we look across British Columbia and Western North America, we see many floodplains are deeply insided with a lot of stranded side channels. And there's a strong need to raise streambed heights. BDAs are a decent start to help invite beaver back, but one of the missing ingredients is that these channels don't have sediment budgets or structural budgets, and these come out of an active fire regime. Fires catalyze the hill slope processes, and erosion events occur, and we think of them as only bad as a result of a century of forestry, but actually pulsed hill slope events are an important part for healthy aquatic ecosystems. These are erosion events, debris torrents, shallow mass failures that bring in pulsed sediment and structure to streams. And these typically happen in tributaries, and channel reorganize events occur and then redistribute sediment, rocks, boulders, root wads, trees throughout main stem channels, especially in the low gradient reaches. And this raises stream bed heights is a counter influence on channel incision, and it redistributes new cold water plunge pools. So this is what reconnects, in our experience, the stranded side channels and helps to increasingly re-wet floodplains that are downcut and dewatered. And this contributes to mid and late season hyporheic exchange. We're finding out that as stream temperatures warm, one of the critical factors is that we're not having functional floodplains leaking this cold hyporheic water into the main stem. So we don't have essentially downstream effects and local effects of cold water coming out of functional floodplains, which of course cool the stream temperatures and add to late season flows, even on some of our smallest creeks. So restoring floodplains rebuilds hyporheic exchange. Hill slope events deliver trees and structure to streams, and arguably restoring fire frequency and severity patterns restores the hill slope processes, basically saying that fire is a key influence on rebuilding habitats for both anadromous and cold water fish like brook trout and west slope cut. All right, some take homes for beavers and BDAs. Restoring floodplains as above creates beaver habitat as well. It invites them back to environments that are beaver friendly. That's a key starting point. Adding BDAs in low gradient reaches can accelerate the process, but again, the point is to invite beavers back. So functional floodplains is really a key. So maintaining this pulse sediment and structure budget is necessary, otherwise channel incision and dewatering continues apace. Again, restoring wetlands, floodplains, and flooding is key, and the fire regime is a big part of that restoration. Take homes for deer and elk. This forest, non-forest mosaic we see as being critical, and that's what we're getting from our big game biologists. And it depends on obviously the deer species and so forth, but having from low to high elevation these seasonal habitat conditions that invite calving grounds and different foraging grounds early and mid and late season is really critical. And dense and closed canopy forests are an enemy of forage production for the ungulate species. We're even seeing that our high elevation sheep are influenced by the loss of fire in some of the highest elevations. Restoring a mix of forest successional conditions is key for not only food, but hiding cover and thermal cover. Restoring aspen broadleaf forest conditions is a key for some foraging elements on the landscape. Restoring a broad variety of open canopy forest conditions is only as appropriate as it is to the fire regime and the forest type. And then restoring wetlands and floodplains is another key, not only for escapement cover, but also for good eating conditions. Restoring wet and dry meadow conditions, especially in the high elevation, colder forests, is a key for having some of those great late season foraging conditions. Again, restoring frequency and fire severity is one key to the process. Here's an example looking at brown bears and lynx and bunnies. I would argue that we know a lot about wildlife habitat use in fire excluded landscapes, but we know less about habitats and their networking in landscapes that have active fire regimes. Case in point is we've got some studies in northeastern Washington where we're studying lynx and hare habitat, and we're finding out that after really big hot fires where some stepping stones were conserved within the fire, that successful lynx and hare are moving back through this landscape, and the returning conditions aren't even 20 years yet. And we've got some kittens on this landscape now, some new kittens. So my argument here is that we have to dedicate some of our efforts to adapting forests and non-forests to changing fire and climate regimes. And a lot of that is a really big landscape idea. Prescriptions for stands won't get us there, but prescriptions for large landscapes where we cooperate with elevation gradients and topography, different topoedaphic conditions, is a key for that smorgasbord of conditions for species that require large mobility landscapes, small mobility, and in between. Each of these conditions were native to the native species that occupied these landscapes before the colonization by Europeans. So there's a lot of non-forest historically, and a lot of it was on forest-capable sites. These features not only change fire size and severity, but these produce some of the critical ingredients on the landscape besides dense forest. So I would argue that restoring active, typical fire regimes is a key to many of these outcomes. This is from a study that we're about to publish on from southern British Columbia, where we're looking at how the map of forest types changes across the 21st century. And the legend here is the dark blue are some of the cold, moist mixed conifer cold forest. The light blue is some of the drier cold forests. This area is in the southern Okanagan. And then the dark green is moist mixed conifer. The light green is dry forest. And then these are grassland and shrubland in the beige to brown. What I want to show you is this is based on some of the climate change suitability ratings that come out of Mackenzie and Mahoney's lab, doing some really cool work in British Columbia and in Western North America throughout. And this is the kind of work that shows how quickly the ranging of forest types is going to be across the landscape. So just take a look at mid-century, what it looks like for cold forest abundance and the increase of moist mixed conifer forest. You can see this landscape by 2100 is going to change quite significantly, and you're going to see different distributions of forest types. And this is that regime under, or this forested area under the active fire regime. So from light to dark green is young forest to old forest. Grasslands again in beige, recently burned is in gray. And this is the kind of thing that you would see year over year. This modeling tracks to your active fire regime and the frequency and size distributions of low, moderate, and high severity patches. So this is a plausible reestablishment of what the active fire regime looked like in this landscape. And what you can see is even though fires are burning, they're not taking out massive blobs. They're taking out smaller areas, and you see small to medium to large size non-forest elements on this particular landscape, but they're still largely a forested landscape. And here's what you get out of those structural and compositional patterns. These patterns constrain fire spread, so fire growth is influenced. The structure of the forest constrains the severity of fires. And here you can see that these forest conditions were burned by a fire in an individual year, 2 fires, 3 fires in an individual year, but you can see it mostly low and moderate severity fire occurring in the dry and moist mixed conifer forest, and the more severe fires occurring in the cold forest types at higher elevations. So you see there's more variety in fire severity, which leads to more variety in habitat conditions. And here's what the role of aspen does in this landscape where aspen is restored. Here you can see with aspen and no fire suppression, this is the amount of time aspen forests obtained through 3,000 years of simulation. So what you can see is the areas next to aspen and conifer forest. So no aspen is right here. These are non-capable aspen patches. But you can see the areas adjacent to them, you have they stay in aspen very much of the time as a consequence of being burned up against and having fires go out against them. And this is a map of fire perimeter density over simulation time, basically reaffirming the role of aspens even under climate change where there's no suppression on the landscape. All right, I'm going to knock it off there, and I hope I have plenty of time left for questions.
All right. Thank you. That was awesome. And you hit on a whole bunch of topics that we were actually met with the province today on. So we'll be sharing the presentation. First question, are you feeling that due to the warmer winter conditions, should we be focusing more research on assisted native plant migration?
I think there's some of that. When we're looking across for the 21st century, most of the environmental gradients, the real bugger is where you see trailing edge environments and there's no networking capability. For example, when certain habitats leave the mountaintop. And so really discovering where you do not have connectivity would be the priority in the 21st century. Across a variety of mountain environments, you're going to see habitat conditions move from the south side to the north side, or they're going to move up in elevation a bit. My big concern is where there's no network connectivity for species that don't have a way to make a living because they become spatially isolated based on where their habitat is. So I think that's the key.
Awesome. Next question. Since the non-forest conditions are very common historically, does it mean we do not need to be concerned too much about the potential forest to non-forest transitions caused by the more severe and more frequent fires? Should the transitions from forest to non-forest be considered as a kind of forest adaptability to the changing climate and fire regimes, or a loss of ecosystem resilience and integrity? There's a lot there.
Oh yeah. Yeah, it's a great question. And the central nugget there, I think, is that non-forests were historically important and they're coming back. Are they the same thing as they're coming back under wildfire? And they're really not. Remember, I showed you the granularity of the non-forest elements to the landscape. And our modeling is showing us a couple things that are pretty darn cool. Number one is patch size distributions are very, very broad. Most of the non-forest elements are small to medium size. We're not getting those out of wildfires, okay? So we're getting very coarse granularity out of modern wildfires, and that's not the physiognomic or life form mosaic that most species made a living in. So the key there is non-forest is going to come back and it's going to balance the potential energy budget, but it's not going to do it in a characteristic way for those forest types or their active fire regime. So we can do more better than just allowing wildfires to write checks, okay? It's a super smart question, but my optimism is that we can actually create better transitions. We have the ability to model climatic water deficit right now, where the potential of vegetation gets exceeded by the actual evapotranspiration, right? These are trailing edge environments. These are places that are basically saying, treat me, create a non-forest element in these particular locations, create woodlands or open savannas in these locations. And then one of the key things in the high elevations is that these wet and dry meadows are really a critical part of changing the fire severity in those environments. A lot of times the meadows are available to burn. So you actually have low severity fires creeping back into these environments and creating more flavors of habitat condition, even in the cold forest.
Awesome. This one's a little bit more specific to BC. The individual said, you might not have the answer. I'm wondering if BC Wildfire has a say in forest management and restoration, or are they limited to the management of the actual fire or fire complex?
My understanding is, and if anybody's in the room that knows better, please correct me, but my understanding is that they have responsibility over fires and active suppression and community protection and asset protection. I think they're very similar along the lines of the Fire Suppression Organization in the United States as well. I think they follow many of the same policies and requirements. You will see in overhead teams that are really practiced that they'll be doing really skookum modified suppression work around key assets, cultural areas that need protection or a certain flavor of fire going through them. We see that with the much more skilled practitioners. And so on our side of the border, for example, and talking to BC Wildfire Service people as well, where they have moderating fire weather and the weather forecasts are for more of the same. If they've got black near them, they have more tools available. to moderate their suppression tactics. And that's just plain good for habitat if they have that window.
Yeah. Yeah, no, that's absolutely right. And wildfire here, their role in the prescribed and controlled burns is typically we have someone else do the prescription, but the burn plan typically is theirs, or they'll get somebody to contract it out and then they come in and deliver it. They've definitely changed in a big way because they were just summertime putting out fires. It's now a seasonal crew. They got some objectives, and they were always, I would say, the folks that were short on capacity and short on time and short on funding, and that is now changed a pile, whereas it's other parts of land management that become a problem. And so what you were saying around land use planning essentially is what you were saying, managing the landscape as opposed to small prescriptions. I think you're right. And that's one of the directions for the province. But until we get to a place where we start talking about the landscape, we're going to be doing 50 and 100 and 200 hectare burns. That's reality for us right now.
I don't know if you saw it, but we just, Malcolm North's lab and mine and Sarah Bisbing, we dropped a paper in Fire Ecology recently talking about strategic fire zones. And here we're talking about planning for managing wildfire or doing modified suppression tactics away from the interface. And we have tens of millions of hectares that are in this kind. Malcolm North is the lead author, and the title includes strategic fire zones. And it's basically saying, let's be clever, let's use all the tools in the bag, where we have the opportunity to develop burn plans in wildlands. Let's have those ready to go so that if we have ignitions under the circumstances when we can take fire for a walk, we actually have the latitude to do that. Mm-hmm. In the US, and I'm sure in Canada, the need to have a plan to understand the fuel beds, know actually how you're going to apply fire sensibly and realistically. Those are core ingredients. So anyway, take a look at that, see if it resonates.
Awesome. We do have a bunch of comments. Price and wildfire folks here says they have teams that are working towards post wildfire land-based recovery, including ecology. There's a link from Dan. Derek said BC Wildfire now has a cultural and prescribed burn program that contributes more to the forest management restoration side of the coin. So that's all correct. There was a question around essentially how kind of every stick and every blade of grass have been allocated in BC, and how do we move forward with getting prescribed burn on the landscape if we've sold off all of the pieces on the landscape. That's a very hard question. Like, where we seem to get traction to get burns is on federal land or indigenous land, and in parks and protected areas is where we seem to be able to make a mile as it relates to burns, or in the wildland urban interface. That's it. So that's a BC challenge, I think.
It's a US challenge too. And if I understand your question, and correct me if I got it wrong, please, Jesse, but my understanding is that the crown lands are the people's lands, and that means that the people can be partners along with the indigenous peoples in determining what the recipes are for large landscapes. And just like in the US, where we've got about 900 million acres of public lands, they're the people's lands. And increasingly, people are getting involved in basically saying that where this is going is not okay. We're standing up for a broader use of tools, a bigger footprint, a faster pace, those kinds of things. And so I'm actually fairly optimistic that people are going to get off the couch as these situations really ramp up, and basically saying, these are my lands and you don't get to watch them burn up. Let's do some clever moves across bigger areas.
Yeah, it's moving in that direction. We have a lot of we have tenure all over Crown land, all kinds of tenure all over it, and so that's our challenge quite often. Is there's a pile of people who have licenses all across the landscape, and not everybody wants fire or even can have fire. So, anyways, things to work on for sure. Right now, we're working in places where we can move the needle a bit, and hopefully, we can move it in a bigger way in the future.
I've been working with Jeff Mycock, Chief Forester at West Fraser, for quite some years now. And he is very much interested in doing the right thing for the landscape. And I think increasing West Fraser's board is as well. So I think there's room for optimism in that it's working together,
Yep.
talking better, yada, yada.
Yeah, we've talked about that a lot. We do have licensees that are keen even to get broadcast burns and cut blocks after it's been logged, or to kind of reduce stem densities and then treat it. One of our regulations kind of forces licensees to use their cut, and if they don't use their cut, then they can lose it. So there's some incentives there that don't match up when licensees are trying to do the good thing. So it goes in both directions. It cuts both ways. Okay, here's a fish person asking a question for sure. How do wildfires impact our BC still waters, i.e. bugs, flush rate, pH, those sorts of things?
Let me look at the question because I'm not sure that came through well for me in the hearing.
Oh, it says, how do wildfires impact our BC still waters? And it says, i.e. bugs, flush rate, and pH. So it's a water quality bottom up. How does it drive lakes and rivers?
Well, my understanding from my fish squeezer buddies is that I'm assuming still waters are the low gradient reaches, basically 5% and less grade, right?
And lakes. By still waters, they'll mean lakes as well. Yep.
Okay, yeah. So if you think about the low gradient areas, especially in the rivers, creeks, tribs, these are depositional zones. And because fish and humans like to live in the same place, a lot of the habitats that are really important are deeply affected by armored channels and allowing for rapid and deep incision. We've got mean stem rivers that are 6 to 15, 18 feet down cut. And so an awful lot of it has to do with the ability to be able to restore floodplains. And that means raising stream bed height, right? To get floodplains working again. And that means you got to have a sediment and you have to have a structure budget. And your sediment structure budget typically comes from tributaries up in the forested areas that have an active fire regime. And that pulsed regime is what liberates the pulsed hill slope processes that at irregular intervals are restoring stream bed height. And lacking that, incision is an ongoing problem, and it's just a worsening problem. My understanding also is that in the US, for example, about 75 to 80% of a riverine system is food pipes yielding food to places where we rear juvenile fish. So if you'd accept a number like 3/4, 1/4, 80%, 20%, which is fairly common, an awful lot of what's happening in the tribs is developing processes for the still waters reaches where juvenile fish rearing is happening. And so it's also those disturbance processes and those fires that are creating the benthos associated with the shrub and tree habitat that is associated with a healthy floodplain and fish that can make a living in an area where there's ongoing hyperetic exchange. So here I'm thinking of the dogwoods and the willows and the cottonwoods and species like that, which are highly attractive to the EPT taxa that fish like to feed on. So in those environments, it seems like this larger landscape prescription is really necessary for those areas. I'm poorly boned up on how that relates to the lake systems. You'll have to talk about to an expert in those systems.
Awesome. Thank you. Okay. With the high intensity wildfires that are occurring as a result of our current forest management regime, what are the main concerns for these vulnerable landscapes with the widespread salvage harvest that inevitably follows wildfire?
Yeah, it's a super good question, and it's laced with a bunch of nuance. I'll give a couple thoughts that I think are key that come to mind. During the period of fire exclusion, a lot of trees obtained on the landscape. So we have more forest and we have denser forest. And dense forest is an enemy of an awful lot of things. It's not great habitat for an awful lot of things, a lot of critters. And furthermore, and this is not an aside, it's actually a fallout of our reburn modeling. we're finding out that the edges that we create, the hard edges we create in forest
Mhm.
patchworks, are totally unlike what we're seeing in the historical active fire regime.
Mhm.
Fuzzy edges where fires stepped up or they stepped down to go out were a critical part of a vast area of the landscape. So you would see a forest edge being 100 to 300 meters wide as a fire would essentially stop burning and eventually come to a surface fire that went out, say in a wet
Mhm.
meadow or wherever, or in next to a hardwood forest. So fuzzy edges are really critical. A lot of different body size and mobility species can find habitat conditions in these fuzzy edges. I think that's a real critical factor. And what was the second part of the question?
It's really around, what are the concerns around salvage logging post burn?
Yeah, thanks. So economic salvage logging is one over the need. The trees that obtain during fire exclusion are still the problem trees. And even after fire kills them, they're going to fall down. And so the trees that ought to be retained and left there are the larger trees that provide a central habitat backbone for that particular landscape. And so it's the fire excluded trees in the smaller size classes that obtain that are still the problem. And so an economic salvage is going to take you up into the big trees. A post-fire restoration project is going to basically say the smaller trees are still the problem and they're the opportunity. And then allow the big trees to become snags, to break off, to become down logs. If you think about it, the longest period in the life history of a big tree is as a dead tree, as a down log, and as char in the soil by 10 times, right?
Sure.
So you can flip it around and basically say a post-fire restoration to deal with the trees that obtained is actually the point, not an economic salvage.
Mhm. Mhm. Yeah, when we did have one of the previous webinars, we had Bob and Lori on, and I
Yeah.
think Bob talked specifically about salvage. So if people are keen on that, check it out on the YouTube. He did cover it, and he said essentially the same thing. We kind of have it backwards. The trees that we're removing are the trees we should be leaving, and the trees we're leaving are the trees we should be removing. And there's a bunch of things around erosion and weeds and compacted soil and all the rest of that stuff. So there's a better way.
I think that's
Um,
right.
Here we go. So this person's talking specifically about the Okanagan work in landscaping, been wondering if you would recommend to plant aspen ecological communities on anthropical landscape as a fire protection, as ecological restoration. Does it sound like a good idea? So if you can kind of expand, because you did have a map of the Okanagan, you talked about aspen. We actually don't have a lot of aspen anymore. That's a problem in the East Kootenays as well. It's kind of just disappeared over the last generation of people. But if you can talk about the value and benefits of aspen, I think that would be great, and how we do post-fire restoration maybe.
Sure. So we declared war on hardwoods, right? And we brushed them, and we hack and squirted, and we aerial sprayed. And so there's an awful lot of places where aspen won't come back unless you restart it. The key question there is, will it be moist mixed conifer or cold forest in the 21st century? Where that is true, reestablishing aspen is actually an important thing. But remember, I showed you the map of forest types is shifting. So
Mm-hmm.
be knowledgeable about where forest types are transitioning across the landscape. Again, the climatic water deficit and vapor pressure deficit maps going forward are going to be critical data to apply on those trailing edge environments. A lot of the moist mixed conifer environments will become dry forests. The ponderosa pine zone and the IDF zone are moving north in the 21st century by a bunch, right? And so being clever about what is where in the future will be the key there. But absolutely, there's so many places where in the historical condition, aspen would bounce out of the hole after a serious disturbance, natural disturbance, and you can get that back.
Cool. This must be from one of the folks maybe in Wildfire too. Said folks should be happy to know we're working on new post-disturbance regional specific native seed mixes for PPAs as well. So that's just an aside filler. You mentioned the effects of the mountain pine beetle on wildfire disturbance regimes, but I was curious if you had any burning thoughts on some of BC's major defoliators like the western spruce budworm and how they influence wildfire behavior. We're seeing it in spruce, and we're seeing a pile of fir trees too that are tipping over right now and dying. So if you can expand on that, that would be great.
Yeah, it's a really smart question, and the answer is varied. Western spruce bedroom is responding to a high degree of connectivity of host species that have obtained across the landscape, kind of similar to that before, then and now picture that I showed, right? If you stop and think about in the interior Douglas fir, let's just isolate on that for a second. Interior Douglas fir was not a dense forest, and so the instars of larvae, when they spin down, a lot of them would end up in the forest floor because they didn't have a tree to go to, and most of them, even trailing on the wind, wouldn't have found a viable branch. They're woodland types primarily, not dense forest. For some of the spruce forest, montane spruce and Engelmann spruce forest conditions, those conditions are becoming more moderate right now, and they're overstocked, and there's too much forest. So again, the patchwork that would have, female moths of western spruce budworm fly badly. Okay, they're more blown than they fly along before they lay their egg masses, and so think about this patchwork being incredibly critical to being able to get connected across the landscape. Mountain pine beetle has to go through a maturation flight to complete its maturation to a full-blown adult. And dispersal losses go up rapidly beyond about a kilometer flight to complete their maturation. And so that patchwork is critical to whether they run out of gas and make it to another stand. In the case of western spruce budworm and Douglas fir tuthup moth, essentially they're seeing fantastic landscape conditions for outbreaks to spread unabated because of connectivity. Also, the climate is making more years, the setup for more years where they can survive and outbreaks can extend and extend and extend. So we see chronic defoliation outbreaks as well.
Okay, there's a lot there. Thank you. Here's a private land question. I'm on a coastal island that is 80% private land. Large scale ecosystem concepts shared are easier to implement on public lands. What tips do you have tips for applying these large ecosystem concepts to ecosystems that have multiple private owners? How do you move these WUI residents to think beyond their property or neighborhood to see themselves as part of a system that needs to be managed? So social science hat today.
Yeah, it's a smart question. We've been talking about social problems that have an ecological explanation, haven't we? And they're going to be solved quite often on the social and political sphere. I'm assuming that the nature of the question is primarily focused on urban and exurban environments, so I'll start there. We've failed worse than anybody in WUI, and so look at US failures in big areas where we've not been ready and we got spanked pretty hard. Those are object lessons, and we're finding out as we look at the national and international WUI codes, they're well built, but each aspect of the WUI code is critical to create success. You can't shop the WUI code. Okay, and you can use those bullet points from the WUI code to basically say, here's how this community, this jurisdiction failed because it wasn't ready. So all of those things are legs on a stool, and you can't take legs off the stool in order to be ready. If the question was bigger than WUI, then that's a whole other kettle of fish, and I would need to know more about that context.
Yeah, I think this individual is really, wondering if you have any experience or anecdotes around getting multiple private landowners to get on the same page and work together, I think is the gist of it.
Yeah, in the United States, we have multi-partner processes now in the Pacific Northwest, for example, where we've developed a landscape evaluation and toolkit prescription, which the Washington Department of Natural Resources has adopted and made a management grade, tool. And we have the Good Neighbor Authority, which allows a number of intersecting agencies to work together along with private landowners that abut these lands. And so increasingly we're developing prescriptions for larger ownership groups that can bring resources, expertise, and that sort of thing to bear on it. But if you stop and think about it, it's being good people, enter into smart dialogue, being open to compromising so everybody gets a bit of what they need. And those are just getting along rules of thumb, right? And people struggle with that and got to get over that before they can solve issues like this.
Awesome. Okay. And I have one just because we were meeting about this today. So this is a question around the northern boreal. So northern BC, Muskwaka, Chica, all of that country. There's a kind of a live discussion going on where we're trying to get some prescribed burns back on the landscape. And what we get back is the natural range of variation is 100 to 200 years. So we're not going to apply prescribed fire. I wonder if you can just give us some insight about how the north is changing and maybe compare it to the south. And then secondly, you know, what does the natural range of variation look like in the boreal now if, you know, 150 years ago was 100 to 200 years?
Yeah. So climate change is happening at triple the rate in the northern boreal, right? Of the Okanagan, for example, BC Okanagan. And so that's a game changer. And an awful lot of it has to do with understanding the fire ecology of landscapes that burned every 30 to 200 years. And that's really the point. We're starting to learn that cold forests had relatively high frequency and low frequency burning. There were a lot of flavors of fire, and an awful lot of that was based on the variability in fire severity that was antecedent to the current fires, right? When you talk to folks like Mike Flanagan, and his point would be that climate change is very, very significant. In the north, couch your what you want to do based on an understanding of what climate is doing to those ecosystems, all the way into the peatlands and above the boreal, right?
Mm-hmm.
Every few years, I take a trip to the northern Arctic, where I'll paddle a northern river to the Arctic Ocean to see the caribou herds and their decline and that sort of thing. And that landscape is changing overnight. It's amazing how many hours I'll fly over fires to get to where I'm going. And so climate is really changing that. And so some of that I would turn around to say, what are the cultural burning needs for the indigenous people there? I think that's a key result area. Restoring the grocery store and the material resources. And they've also got significant insights for how to burn that country. Another thing I would say is, what is it that you want in terms of carbon sequestration in the long haul and having those ecosystems in good shape, to not have peatlands burning year over year because big fires started, right? 2024 fires in the Northern Boreal were holdovers from 23, right? So many of them. So I would say an awful lot of it is, what do you want for those ecosystems? Or do you just basically assume that climate change be coming and it's just going to burn those lands? I think you have some opportunities to put better fire on the landscape, even though those fire regimes don't obey the rules further south. They're just very different.
Okay, great. And maybe let's see, we'll wrap it up here, but maybe one more question. What are you folks doing south of the border around post-fire restoration? Is there applied work going on in terms of, you talked about BDAs, that's live, we're doing it as much as we can right now, as many places as we can, but is there active kind of land restoration going on post-fire in the States?
There is. I draw your attention. We had a grant we recently published on about a half a dozen papers, called the New Fire Project, and it's primarily focused on what you can do in post-fire environments. So Andrew Larson led a paper, he's from University of Montana, on some core principles for post-fire landscapes. Take a look at that. It's essentially given us a way to think about how you triage a landscape that's been burned by different flavors and sizes of fires. Okay, and that paper basically says this will help you diagnose the landscape in terms of unfinished business, areas where the landscape needs a hand down, areas where you got a good first entry fire, keep the music going, right? Alina Kanzler, also University of Montana, she led 2 other papers in that series on the effects of fires on future fires. Let's see, Derek Churchill wrote a paper. He's a scientist with the Washington DNR Forest Resilience Group, looking at how you actually take real burned areas, diagnose them for the work that you're going to do. So I take a look at some of those resources. I think they're pretty heady. And then I would say probably an overarching idea is that in the United States as well as British Columbia, the footprint of fires is much larger than the green tree work we're doing on the landscape. What does that tell you? It tells you that wildfires are going to carry a lot of the water in the future. Can you bust out a big idea for post-fire landscapes that allows you to take good work and keep it going and eventually count it in your acres treated, right? So if fires burned with moderate or low severity fire, how do you keep that magic going on the landscape? Where you have the right size in the right location of high severity fires, what do you need to do there in terms of forest reburning in order to be able to create conditions that won't just keep burning like that? Where you have big unbroken areas of high severity fire, what's your recipe for tailoring back to the terrain the kind of conditions that you want going forward? So I think those papers give some idea of how to triage a landscape, how to focus on different conditions as you encounter them. I would argue if we don't address the post-fire landscapes as one of the most important jobs, we're missing the boat. It's the biggest deal going on in Western North America. Why would we not do a great work there?
Yeah, I agree. We're in the stages where we're even just trying to figure out a way to get seeds so that we can put it back in where we have high severity. So as always, we're a long ways behind you, but we're getting a lot of burns. So maybe we'll get some funding to help support that work.
In the Sierra Nevadas, the folks are looking at, because of the lack of planting stock and the seed zone supply, planting tree islands, giving burned areas the ability to naturally regenerate back to forest. And so that's kind of a step in our triage of post-fire environments to get the right species for climate change on the landscape established. And then those islands give us the ability with the right burning regime to be able to continue propagating that regeneration and release of trees on the landscape.
Awesome. Well, I think we'll cut it off there. Dr. Hessburg, awesome, phenomenal scientist, even better communicator. Really appreciate it. For everyone who's on, if you can share it with your coworkers, your friends and family on your social media, this is great information for BC. Fires are not going away. So we're going to have to figure out a way to work with this tool as opposed to pretending that it's not going to keep happening. I've been told to put in one plug. We have our Ticket to Adventure, which is a whole bunch of fishing trips, houseboat trips, skiing trips, our lottery and 50/50, which we just started, which will go all the way through to December. So if people want to buy tickets, that's great. It helps us do educational work like this and deliver our Beaver Dam analogs and wetland restoration projects. So Paul, thank you very much.
Fun hanging out. Thanks folks for showing up. Cheers.
Awesome. Thank you all. See ya.